you all to our next presentation on nuclear energy in our IEEE presentation series on nuclear energy. My name is Maike Luiken, and with your permission, we will record this meeting. It's been turned on, so you're aware. Today, it's my great pleasure to welcome Dr. Jan Emblemsvåg. He is going to talk to us about nuclear propulsion for merchant shipping. And you may ask why we have this presentation series. It is really born out of the need for clean, sustainable energy. Ban Ki-moon in 2014 made a rather profound statement about the role of energy to achieve the sustainable development for the planet. He said, energy is the golden thread that connects economic growth, increased social equity, and a healthy environment. Sustainable development is not possible without sustainable energy. And I think out of that came a lot of the discussion and the true understanding of the need for global energy systems transformation. So you may ask, what is the role of IEEE? Saifur Rahman, a past president of IEEE, stated it as follows: ensuring that our response to climate change is substantial, appropriate, and properly engages IEEE, its members, and the larger technical professions. So he had a focus on climate change, part of the energy systems transformation agenda. IEEE provides for these discussions a neutral platform, and that's essential. And it functions as a technology provider because, as we all know, innovation, technology is essential for us to move forward. This presentation series was conceived essentially to start with at the IEEE Vancouver section, looking at the need for nuclear energy, also based on the statement out of COP28 that nuclear energy has to be part of the mix going forward to power our infrastructure. There's a number of partners with the IEEE Vancouver section, IEEE Future Directions, the IEEE SusTech initiative, the IEEE NPSS, IEEE SA, and the Planet Positive 2030 initiative. This presentation series is intended for a broad audience, not only for engineering and technical community. It's aimed at regulators, policymakers, community stakeholders, industry, etc. So it's really for the general community with an interest in the energy transition, clean energy, energy alternatives, nuclear reactor technologies, and all related topics. And ultimately, it is aimed to serve the needs of the profession and the public by increasing awareness and understanding of nuclear technologies so that we all may make the right, or whatever we perceive at the time to be the right decisions. Today's talk is going to be presented by Dr. Jan Emblemsvåg. He is at the Norwegian University of Science and Technology. And we're really happy to have you here. He's going to talk about a topic that is maybe not as, in the forefront of today's discussions, but he's talking about nuclear propulsion for merchant shipping. And we know nuclear propulsion is certainly practiced in the oceans for military purposes, mainly today. But he's going to look at why this needs to be extended for merchant shipping and what type of criterion need to be used in the selection of reactor types, what reactor types have come to the forefront, and all over what is it current status of developing and potentially deployment of this technology for merchant shipping. Just to remind everybody, here's a list of topics that we are addressing in this first series on nuclear power. We have, after this talk, we have another 4 in the series. And just let you know that the team is working on discussing the next series. And so I'd like to invite all of the attendees to propose speakers and topics in the chat for the second series on nuclear energy. I've got a couple of links here, QR codes. There's a QR code for the main series page, and also a QR code for a email list where you can stay in touch with all our different efforts in this area. And I'd like to put a little plug in for the next talk on June 18th. It is on micronuclear energy, and it is really looking at this energy source for the securing of Canada's Arctic sovereignty. So as you know, there's a lot of global warming discussion, and there's a significant rise in temperature in the north. So current infrastructure has issues. There's also much more shipping in the north today, so much more access to the north by other players. And so looking at remote communities, looking at remote installations, and how microreactor technology can help powering that infrastructure will be the talk of June 18. And with that, I'd like to invite Dr. Jan Emblemsvåg to talk and take over the screen. I will stop sharing right now. And here you go. It is your audience, Jan.
Yes, thank you very much. And thank you for allowing me to come and talk about my favorite topic these days. So let's see if I manage to share. That's the first test here. Let's see, I think I just shared the screen. Here we go. Oh, it's a lot of windows here. Let's see. Close on that one.
Yep.
Perfect.
Here you
Yeah,
go.
you see it?
Absolutely perfect.
Oh, well, then I guess I just start.
Please go. Yeah.
Okay. So, why did we start looking at this? Let's see. I have a window over here. Oh, there it went away. Well, in 2015, I think it was, I was senior vice president in Rolls-Royce Marine with global responsibility for ship design and system integration, and the whole zero emission shipping idea came along. Back then, of course, we worked on LNG and those kind of things. In 2020, I left industry and went to academia. So then I started picking this up again. And if you look at the total consumption of fuel in the marine industry, maritime industry, there are different numbers around, different sources. These numbers are based on UN numbers and made some adjustment for growth because those UN numbers I had were a little bit old and I was not able to find very accurate data. So you see total about 395 million tons. Let's say we're now going to replace this by green ammonia, for example. Then we know green ammonia has half the energy content, and it requires 12 megawatt hours per ton in producing it. And by just calculating these numbers around, you get a very interesting graph, and you can see it here. And here is the red line. This is what the energy requirements would be for green ammonia for shipping. And then if we start comparing to some big units here in the world, you see, for example, EU, you would need 3.7 times all the power production in EU, not just renewable, but all power production. You would need 2.5 times all the US or all the European. You would need more than all of China. And if we include losses in transmission and everything, I think it is not far from truth to say that we would need roughly all the power in all of the OECD countries, which meant we could not have this presentation. And obviously, this will never happen. It's that simple. So that's why we really need to think about this in a fresh way. Otherwise, we will end up, like I say in the heading, it will either be fossil, sorry, it will stay fossil. The alternative is really nuclear. That doesn't mean that there will not be niches where you can have some green alternative fuels and some other things. But in the grand picture, I think this heading is very correct. And then, of course, the whole reason for looking into nuclear has to do with energy density. And here's a nice chart from DNV. And you can see diesel in the cross, so to speak. And the red region is, of course, solutions, fuels that are worse off. Then you see some of them have arrows. For example, LNG is in the light green, but with the arrow, it's in the red. And this is with or without equipment. And of course, you cannot use LNG without equipment. And of course, if you look to the right, hydrogen is also impossible to use without equipment. So when you include the equipment, then we are really in a bad shape. And hydrogen is a very problematic molecule, hydrogen gas. In my last industry job before I came to academia, I was heading a company who made pressure vessels for the oil and gas industry, thick pressure vessels too, so with a lot of complicated welding, etc. And hydrogen gas is one of the worst things you can get up from an oil well because it leads to welding stresses in the welds, can even lead to failures, can lead to failed steel structures, etc., etc. So it's a very difficult molecule to control. But assume that those long arrows are 1 meter, then uranium would be 32 kilometers away from you are sitting now, and thorium even longer. And I think this is really what the green transition has to be about. When we change energy density from what you see here on diesel to something that dramatically different and better, then we really start talking. So we are looking at basically two major opportunities. One is, of course, to put the nuclear reactor directly in the ship and have so-called direct nuclear propulsion. And we see a lot of possibilities here, as you can see, faster ship, no emissions, walk away, safe, even lower cost. We'll come back to that. There are, of course, challenges, obviously. We can also make synthetic fuel by using, for example, big nuclear facilities on land, and then make basically fuel either from the rest heat through thermochemical processes or through electrolysis using power. But as you saw on the graph or the slide before, that leads to a lot of losses. But it is possible, absolutely. So in our research now, we have discovered that if we have more than 5 megawatt installed power requirements in a ship, then direct nuclear propulsion is the best. Smaller ships, aviation, trucks, and those kind of things would probably need synthetic fuel. And by the way, aviation is almost as bad as shipping. So when you take aviation and shipping together, the challenge is really massive. So we did our first initial analysis this is an Aframax tanker. And as you can see, it's actually the second smallest of the what we call deep sea ships of tankers. A deep sea tanker, deep sea refer to the part of maritime industry that basically crosses the world's oceans from Europe to US, Canada, from Canada to, China, across the Indian Ocean and so on. The long stretches, that's the deep sea. We were lucky to get some data on it, which made this calculation possible. And here you see the engine of it. It's a two-stroke heavy fuel oil engine from Wärtsilä. And this is actually a quite small two-stroke engine, by the way. It's a 15 megawatt output from the electromotor that drives the propeller. We looked around and we found the Fuji reactor concept in Japan, a molten salt reactor. And the smallest one had the same output. So essentially comparable. And then we tried to do some economic estimates. And assuming 6.5% weighted average cost of capital over 30 years, the net present value is shown in the graph below. So, and as you can see, the molten salt reactor actually outperformed the heavy fuel oil. And in this case, if you take a look at the average values, it's about $70 million difference over 30 years. But you see those two distributions overlap, meaning significant amount of uncertainty. This analysis, as you can see, was published in 2021, so it's 5 years old. I will come back now with a little bit more updated soon. But first, a little bit more about what we've done. So this led to a more generic question. Can really a molten salt reactor or any other generation 4 small modular reactor for that matter outcompete heavy fuel oil head on without subsidies? That led to the NUPRO ship projects and nuclear propulsion for merchant shipping. And this is the abbreviation. First number 1, and now we're doing number 2. But in number 1, as you can see, it's a concept feasibility study. And I will go through some of the main things we discovered in 1. In number 2, we're basically doing more of the same, except much more details. We start to look at end of life. We start to think about stakeholders, the whole propulsion system, the load management system, etc., etc. And today, we just submitted the proposal for funding for SFI SAINT, which is essentially a research center on nuclear propulsion at the university here, together with our partners in NUPRO ship that I will also come back to later. And we hope that this whole sequence of projects will actually lead to a demonstration project. So how did we arrive at the reactors that we're now working on? Well, we basically took all the known concepts by 2022 in the IEEE and also the Nuclear Energy Agency of the OECD. Then we developed 11 exclusion criteria. And if we'll go from left to right, first starting at the top, of course, if it's too large, we can't use it. If it's not mature enough, we can't use it. Light water reactors, we also just took out immediately for a number of reasons. One of them is actually political. Light water reactors have had too many smaller and bigger accidents to make them work politically in our technology that will have to go from port to port, country to country. But there is also more scientific reasons to put it like that. It's also they need too large emergency zone, protection zone around them because of the pressure, for example. Or they have also proven to be too costly. Then no classic high temperature gas reactor pebble bed technology because of the pebbles will rub up against each other, create potentially dust in the reactor, and that could be a problem. Then, of course, proliferation, very, very important. Safety, very, very important, of course, and we do not want reliance on active safety systems. It has to be passive or inherent. Then, no violent interaction with water, of course. That's a very bad property on a ship. We also put pressure limit far lower than we have on the light water reactors. This is the purpose of that was to make sure that the containment structure is really the safety area of the reactor, so that it is, from a regulatory point of view, safe to walk outside the containment structure. It has to manage at least 5 years continuous operation, because every 5 years ship has to dock, and that would be a really, really good thing. And then finally, no export control issues. So this was the initial 10. Then we start to do more work on this. We also realized that enrichment, but also highly toxic byproducts could be an issue. So that's the 11. So we went from basically 80 some reactor concepts, and this allowed us to trim it down to, I think we were down to 8, if I remember correctly. Then these 8 were subjected to 26 selection criteria. These are not on-off kind of criteria. Here we're talking about degrees. When we start working on this, we realized that the cost numbers for different vendors were, what should I say, unclear. It was not clear to us what they had included and not, and so on. So basically, we decided to, okay, let's put the rest at that. We're taking a new ship number 2. Then we also learned a very interesting case about the proliferation rules that basically inhibit molten fuel, molten salt reactors with molten fuel in and out of a port. Basically, the IEEE would like to have a counting mechanism that's very, what should I say, robust. So they need countable fuel. And the problem with our molten salt reactor is that you have almost the entire periodic system in the salt at times, and keeping the exact, which is a radiological account, requires measurements that are not agreed upon. So we just realized that this would probably be, who knows what, could go, 1 decade, 2 decades. It could go a long time before something like this would be allowed. So we parked them. So then you can wonder, are there anyone left? And there are, actually. We ended up with a helium gas-cooled reactor on TRISO fuel. We ended up with a molten salt reactor on TRISO fuel, and a liquid lead reactor using uranium nitrate. All this scored very well on our 37 criteria. So, a little bit about the TRISO fuel. We believe that could be a maritime game changer for a lot of reasons. First of all, it contains everything that people are so scared of, which is a good thing. Second, it makes misuse of the fuel very difficult. You have to be a very advanced actor to be able to handle this. And for such an advanced actor, it's probably easier to just do it from scratch if they want to make weapon or whatever. Third, it can take a very long time in seawater. We saw one article that said more than 10,000 years. So there are a lot of good things about this. And this is the particle, as you can see, it's 0.8 millimeters large. And then one of the reactors use these kind of pebbles. So this is a TRISO pebble. And for those of you who recognize this, it's from Kairos Power, yes. And then in the other one, this is from the MMR reactor, the one to the left in the other slide. Basically, a same kind of concept, but even more compact, more ceramics. So very difficult to misuse any of these fuels, and that's why we think this could be a really game changer. Another thing is that the marine industry has a very high alternative cost. So some people have asked me that, well, this will be too expensive because it's more expensive than uranium oxide on land, and and take a kind of like a land-based line of arguments. It's just that the alternative cost for marine is completely different. So we've done analysis of this that shows that the fuel is actually cheaper than heavy fuel oil. So then we're left with the other things, the reactor, the steam turbine versus the diesel engine or whatever they use today. And then we have the benefits of longer range, higher speed. So that's why we are actually believing that this study that we did 5 years ago is still holding true, meaning that it is more beneficial. So we have a number of cases that we work on. Here's one, it's our LNG tanker. And in this case, we realized that molten salt reactor and steam turbines would be a very good fit. Then we have also a smaller helium gas cooled reactor. This is designed by the reactor designers that used to work in UltraSafe. Many of you are probably aware of UltraSafe being in Chapter 11 last year, and that had to do with, I think, mostly strategy issues, really. So the new owners want to take the company in a different direction than the past, and that enabled the guys who work on the reactor design to basically set up a new company called Emerald. And we have worked with them for 2, 3 years. So they now designed a marine version. And this is a very nice little package, 5 megawatt. And you see the sizes, very, very handy. And you combine it with a supercritical CO2 turbine, and you get something that's really, really interesting. This is something that would fit in the typical ships that we build around here. When I was running one of the shipyards in Vard, I don't know, 10, 15 years ago. And we built many of these, of course. And this is a really ideal fit for such a kind of technology. And we just submitted an application, actually, where we will look at obtaining the funding required to make a digital twin of one of these fossil versions. These were under construction right now as we speak. Then we can make a digital twin, feed it with live data, and we can prove that this digital version should work. And then, of course, the next step will be to build one. And the third one, the lead-cooled reactors, they don't like ramping, essentially. They need 80% load, at least. But there are many, many applications in the maritime industry and also offshore or oil and gas and land-based power. So many opportunities where a floater like this would be very ideal. So all these 3 use cases are now being studied in NuProShip 2 and will be taken into the research center if we get the funding, of course. Yeah, here's the work packages, just a little bit more. So you see nuclear island, ship safety, VP2, VP3, operational safety crew maintenance. This is from NuProShip 1 being carried over in NuProShip 2, but we've added 3 more packages. So balancing ship power plant, remote monitoring, operations, cybersecurity, and of course, stakeholder involvement. Here are now the current partners. The project, since we started 4 years ago, has grown a lot in the number of partners. So you see shipping companies here, you see Norwegian Maritime Authority, DNV, the class company, VAD, my former employee, shipbuilder, ship designer, insurance companies, other universities, shipowner association, Siemens Energy on the turbine part. And also here we have Peregrine Turbine Technologies. We have the 3 nuclear vendors, and finally, also Semper, which is a communication specialist company. This has to do with the fact that we believe we need really, really, really foolproof communication to prevent any sort of hacking or any sort of, doubt about the possibility of being hacked. Focusing right now, well, the modernization of the reactors. We are working on a demonstration roadmap that is covering these two vessels that I just showed to you guys. They have separate funding. The floater, we are still working on engaging with the customer on that. We would like to have our active customer in the project like we have for these LNG tankers and offshore construction vessels, because with an active customer, you get all the nitty-gritty details that has to be addressed correctly. Otherwise, it is not realistic. Operations, of course, the ship power plant, stakeholder engagement, and of course, this SFI application. Upcoming conference now in June. This is on the 17th of June. So if you want to hear a lot more about this, then you should. Well, it's the final call for this conference right now, actually. So you need to react quickly by Friday. But this, then you can hear more about it, of course. Yes. So that's it, folks. I think then you probably have lots of questions.
Well, let's start with a thank you to you. Thank you for joining us and presenting your work and your team's work, and giving us a true view of what is happening around the potential of nuclear-powered merchant fleets and so on. So I do have so far one question actually in the Q&A. And that's from Wolfram. How is TRISO different from the pebble bed reactor that you rejected? Also, I thought you rejected all lead-cooled reactors because of polonium production. So if you could, and take your time, we've got quite a bit of time. So
the first one, the thing is that in a helium gas-cooled reactor where the pebbles move around, they will rub up against each other. But in the molten salt reactor, there's a positive buoyancy, and they will just float around. Of course, they will be still tied to each other, but the molten salt will prevent them from having any significant rubbing. So that's the reason why in the molten salt reactor they work, but not in the helium gas-cooled reactor. And then, of course, in the helium gas-cooled reactor we actually did work, then they don't move. Then they are stuck. So there is, and that's not pebbles; it's pellets. So that prevents the movement. The second question, also very good. In lead bismuth reactors, then you have a significant production of polonium-210. But in a pure lead reactor, it's very, very, very little. That's why we kept the pure lead reactor, but we rejected the lead bismuth reactor. The price we paid for that is that the pure lead reactor, they don't like ramping, which means that we have to look for this kind of baseload applications for that one. But there are lots of baseload applications out there. Yeah.
So it's not as flexible, so to speak.
No, you can't ramp them enough down. So yeah, for a ship.
Okay. Okay. There was another question from Wolfram. Curious, you didn't mention the NS Savannah, the first and only nuclear merchant ship launched in 1959. And maybe you could comment on lessons learned from that ship.
Yes, and I mentioned the politics around light water reactors, and Savannah is a very good example of the politics that took place, because when Savannah was going to go to a port somewhere, they had to send a team, month in advance and negotiate access, etc., etc. Something that can never work in the commercial world, and that's why we have taken a great care of selecting both very robust fuel and very robust reactor designs to avoid this kind of discussions that you have around the light water reactors.
So that brings up a question that I guess within our team planning the series came up, and that was the licensing. And so, like right now, nuclear reactors are licensed, quote unquote, by each country. They have their
Yeah.
own schemes, their own regulatory environment frameworks, and so on. So, how is this going to be done with the merchant vessel that goes from one country to another? Like, how do you deal with the licensing issue?
Yes. Very, very good question. And the way we approach it is to basically, we would like to do it more like in the aviation industry. If you have an airport in a country and you are going to become an international airport, you have to set up a bunch of multilateral or bilateral agreements between those countries who are involved. And we think a similar model for nuclear shipping will be the way forward until we have a more, what you say, a more generic acceptance around the world. So the use cases, the two use cases where we have customer and everything, we are actually looking at a handful of countries. Let's see, 4 countries, and so we just need to do this permitting in 4 countries, and the ship owners, they realize that, okay, these ships will only be allowed to go in certain routes, but that's okay with them. And what we are then basically making a bet on is that once people see that these ships are out there performing nicely, safely, then more countries will come. And we will roll it out basically in response to demand. And these ships, they will most likely be cheaper than the fossil ships. They will be faster. They will have less downtime.
Mhm.
So there are a lot of, and of course, no emissions. So there are a lot of benefits. Yeah.
Interesting. So essentially, you would have an international zone at those ports where
Yeah.
specifically those vessels could dock
Yeah.
rather than anywhere. Yeah.
Yes.
Okay. Interesting. So is that under discussion with CIAE or where is what is happening?
Yeah. And now we are reaching out to the governments in these countries
Okay.
and present the project so they can see the potential here, and hopefully they like what they see.
It'd be an interesting piece to look at developing standards for that type of setup.
Yes, DNV, the class society in our consortium, they are now also aligned with Lloyd's and ABS. Also, I think all of them will now issue these nuclear codes.
Okay.
But of course, one thing is that the class societies issue a nuclear code. In the end, this will be flag state, port state issues.
Yeah. Yeah.
That's why we need to engage with the governments.
Yeah. So thank you very much. So I figured this would be one of your barriers that you have to cross, right?
Yeah, personally, I consider the politics around shipping to be the most difficult part of the entire project. Yeah, yeah,
Thank you. I got three more questions here right
yeah.
now. So one is, are current reactors used in military applications based on the light water design?
Yes, they are, and but they are under military control, and they use fuel that we are not allowed to use, which give them long range. But if we were to use, for example, uranium oxide that you use on a traditional light water reactor on land, we would not be able to do 5 years.
Okay.
Yeah, so that's another reason why the light water reactors will probably not survive in marine market. They are, uh, yes. Hmm.
Interesting. Like I'm from Canada, so we have the CANDU reactor. So it
Yeah,
just continually you can do continuous refueling. So you
yeah,
don't even have this 5-year limit, right?
that's
But
true.
yeah,
But then you would have the proliferation challenge when you
yeah,
go abroad into other ports, etc., etc. So
yeah,
yeah,
yeah, yeah,
with
understood.
current rules. Yeah.
Yes. So this question was from John and Nessis, and the next one is
Yeah.
from Clayton Burns. Would it would it be set up that the steam turbine just turns the generator and the drive is via electromotors, or would the turbines drive the props? Would the working fluid be steam or carbon dioxide?
Yeah, we are considering all those options. Currently, we use the term nuclear electric,
Okay.
which means nuclear and electric drives supercritical turbines, or we use nuclear mechanical, which means nuclear over to propeller. Um, and if we look at the conventional ships that use steam turbines, the nuclear mechanical is most effective for the big ships because you have losses in the electro motors, etc. But that was 20 years ago. Now we're doing a re-evaluation of that kind of setup, and we'll see. But that's part of our one of the work packages is now studying these things. Yeah.
Okay, so another question that's open right now.
Oh yes, I mean there's tons of research to to look at, So yeah.
Okay, Wolfram had another question, and he's talking about, of course, those big villages that are moving around the ocean, like cruise
Yeah.
ships, maybe more like small cities. So they're becoming huge. So are there any thoughts of targeting those? Because, this is just a comment from my side. Of course, we know that they generally burn bunker C.
Oh yeah. Oh
Yes,
yeah.
and
I mean the cruise ships they are really fuel intensive. Just or a big container ship. Just as a small fun fact, a big container ship steaming consumes about 30, no 300 tons of heavy fuel oil every day. And that is enough to empty the world's biggest grid battery in just one day. So they are massive consumers of energy. The reason we haven't targeted the cruise ships is that we believe that first we need to demonstrate the technology on ship types where you are more on a terminal to terminal kind of operation away from people. So, for example, LNG tanker is a very good candidate because it never comes close to any city centers. It just terminal is out there somewhere. So yeah, the cruise ships would have to come into a harbor, and that would be much more tricky. Yeah,
yeah, and their routes are based on, 10 stops, 15 stops. So
yeah,
so you have lots of port negotiations and country
yeah,
negotiations to do.
yes.
But ultimately, in terms of their replacing their fuel would be highly beneficial if we can make it
Oh
come.
yeah, oh yeah,
Yeah. So I'm now moving over to the chat. There's a couple of questions in there I think I'm be discovering. So there's, first of all, there are a number of thank yous for a very nice
yeah,
presentation. So thank you.
yeah. Very
And
nice.
here's a question like, do you see any of these light reactors being used in aviation in the future?
Oh, that's a very interesting question. I've been thinking about that outside the project. I can just tell you my personal view, and the molten salt reactor actually came out of a strategic bomber project in the U.S. The air, the what was it called, ARE project, where they actually fitted a beryllium reactor on a strategic bomber, and if I remember correctly, it flew for 250 hours non-stop. Yeah,
Wow.
but expensive, heavy. But who knows? I mean, if we can make very small reactors, very light, maybe, maybe it could happen. Yeah.
Another topic for future discussion.
Oh, yes.
So let me just see. I'm just lost my page here. My spot. Yeah, one question came up again, how licensing issues would be handled at different ports. I think we might have answered that,
Yeah.
unless you want to add to it.
No, I think, like I said, through bilateral agreements between the countries involved, that's how to do it. But That being said, it might be also wise to emphasize that we do believe that we would see a kind of nuclear port system in the future, in the sense that some ports will be allowed to have nuclear shipping, others will not. And it has to do with the licensing of the port. And some ports may find it economically too costly to license themselves for such kind of ships if the traffic is too small.
Okay.
Yeah.
Interesting. So let's go to some of the others. So one of them is on container vessels, and whether container vessels are actually in the 5 megawatt range.
No, for the container vessels, then we need, depends of course on the size of it, but we're typically looking more from 20 up to 60 megawatt, depending on how big it is.
Okay.
Yeah.
And so how big will the SFI Saint be in size? Like compared to
Uh,
another tanker, or how much power will it give?
the SFI Saint, that's the research center.
Yeah.
That's the nickname for the research center. But we will look into all major ship types
Okay.
in that research center. And in the consortium, we have hundreds of ships under flag, and some of them are very large. So we will study some of the larger ships in the world, all the way down to really a relatively smaller one. And I think a 5 megawatt installation, then we're talking about ships down to a size of 100 meter.
Okay.
Yeah.
So at the research center, uh, you are not actually building a prototype or anything like
No,
that.
we build digital twins of them, full
Yes. Yeah.
scale
Yeah.
digital twin, and simulate them, and yeah.
Okay. There's another question, this one from Douglas Cromie. Have you considered single point failures and the risks that a ship may go out of control as a result?
Yes. So these use cases, the class society, DNV, they say that this will be under Circular 1455, under IMO regulations, which mean that we need a 100% redundancy solution. But that we were fully prepared for. We had the same when we built LNG powered ships
Yes.
15 years ago in my previous job. So we know how to do that. It's not a big deal.
Yeah. So
Yeah.
full redundancy, no single point of
Yes.
failure.
Yeah, we need that on the first ships. Yeah.
Yeah, I think it's yeah. It's interesting how single point of failure considerations actually have changed many designs,
Oh
plant
yeah,
designs,
yeah,
airplane designs, ship designs, all kinds. So it's really been pervasive.
yeah.
Yeah. So here's another question from Cynthia. You mentioned the crucial role of communication. Did you
Mhm.
study the potential reaction of anti-nuclear groups? And if yes, what would be the strategy used to interact with them? Because you mentioned stakeholders.
Yes, and Newpro Ship 2 started in January this year, so we haven't really come that far to study how and exactly how to do the stakeholder engagement in marine. But it's definitely on our agenda, and it's a very, very important topic. Bear in mind the Mutsu ship in Japan, for example, that's a classic case of failed stakeholder engagement. So we cannot come to that kind of situation. Very good point.
Yes, it's interesting that this question comes up. So the planning committee for this series had a number of goals, and one of them really is to um, try to address misconceptions and
Yes.
misinformation about nuclear energy, right?
Yeah.
So that's really where we are. So um, I see more compliments.
Yeah. Thank
Uh,
you. That's
the
always nice.
okay. So here's a question from Brent Kimberly. Will the ship require remedial action?
Remedial as in,
Remedial action is used for LR/GR, like load rejection and generator rejection?
I'm not sure if I understand the question correctly, but there will be redundancy solutions. But if remedial, as in, will we do maintenance and that kind of things? Definitely. We are actually planning with shorter maintenance intervals in the beginning, and then they will be extended as we see everything work according to plan. So, yeah.
Typically, remedial action is used on nuclear plants where the the bulk electrical system could cause burnout. Long lead items like transformers is used for equipment protection, and so do you see the need for equipment protection? That's really where I'm going.
Oh, okay, yes. We do have that on the offshore ships, and these ships we built, they are to prevent blackouts, I guess, is the
It's an asset management thing. Like so
yeah.
some environments, if you're not careful, you can as the stability changes, you can destroy your transformers, and if your transformer
Mm,
takes 2 years to
yeah.
repair, it may impact availability of the ship. That's really where it's going. Thank you.
Mm,
Thank you, Brent. I think I'm out of questions unless I missed something. So if
yeah.
somebody had a
See.
question that I failed to
There
discuss,
was one here from Yan Huang.
yeah,
What
just came up.
design? Oh, they went away. What design standards?
Yes, I just see it. Peter Lang, what design and safety considerations are necessary to deal with piracy and ship
Yeah.
hostage taking, such as currently exists off the Horn of Africa?
Yes. For the first ships, we don't think they will be in the Indian Ocean at all. They will be in peaceful waters. But that being said, many ships that are now being built actually have citadels, which is highly protected, which means that it's extremely difficult for pirates to take over the ship. And also this is where the triso fuel comes into play. Even if they did succeed to take over a ship, so what? They will have all this triso fuel that they can't use for anything.
Hmm.
So we have basically thought about a multi-layered defense approach when it comes to such kind of actors. But also keep in mind today, the primary action that ships do is to actually speed up and outrun the pirates. That's the first, yeah.
First
And
line of
normally
defense.
that's sufficient. Mm.
So that's the first line of defense.
Yeah, just outrun them.
Right. Well, any other questions? Cynthia, Charles, Ahmed?
It's a lot of very good questions.
Well,
I
they're
just
all
posted
waiting.
another
They're all
one,
waiting
Mike.
for you. Pardon?
I just posted another one, but since I'm there verbally,
Yeah.
I'll say it. A use case I've heard of for ships with nuclear reactors is not so much to transport cargo, but to provide power to coastal cities, either remote locations, underserved, or during emergency cases. Like I can imagine like a tidal wave wiping out infrastructure and providing temporary power to those locations. So that would require definitely a larger reactor than normally what you're considering. But anyway, I just curious if you've been thinking about that at all.
Yes, that's this floater, the third use case. That's a type of asset that can be used for such applications. And the sealer is a 55 megawatt electric reactor. And if you have two of those, you have a 110 megawatt installation, which is big enough to power most smaller communities and so on. So I know the Russians have built one of these already, and I think they're constructing number two now. Yeah.
I was thinking of emergency applications, except in emergency, you won't get the license that quickly.
No, that's absolutely.
Yeah, sorry for like jumping in there, but So I think there's lots of different applications that
Yeah.
people are bringing forward here around our virtual table. But we still have the issue of licensing, and
Yeah.
I think I'd like to come back to the point of trying to figure out a way to come up with the standard process
Yeah.
for this licensing issue, and maybe some other folks can work on that at the same time.
Yes, that's actually our work package number one in the research center is a very legal, regulatory, heavy work package because we see this as one of the critical things.
Yeah. So I'm looking back at the chat and see whether I see a couple of links posted for people to use. So, and I think we're out of questions. I'm going around 3 times, once,
Yeah.
twice. Anybody speak up who has a comment?
Those two links just give a bit of background on remedial action, and they just point to Alberta and to NERC. So thank you. Have a good day.
Yeah, thanks for posting your link there, Brent. Cynthia, you have a comment?
So first of all, thank you so much for your presentation. It's really very relevant, giving a lot of ideas and inspiration. And I wanted to ask you if you would be available for further discussions and maybe common work.
Yes, absolutely. So just send me an email. We'll take it from there.
Thank you. Thank you very much.
Yeah, thank you.
Do this. I think I found one more question here.
Yeah.
Just came in. It's from Wayne Lee. Thanks for the great presentation. What considerations are given for capital cost upgrades to ports and terminals to support these new ships and retraining costs?
Yes, that level of detail we have not arrived at yet. But we have been talking to a couple of ports. And to my amazement, they were actually very positive. And now I'm talking about not terminals, but ports where people are in cities and so on. And one of them, the first reaction to one of these ports was that if these ships come along, we don't have to do all this bunkering, all the infrastructure for fossil fuel that we have today. It will actually make the port job easier. So he actually just saw positive things. Yeah. But of course, there will be a licensing job to do on the port, and there will be limited access to the ships. But that we have today already in a number of ports under ISPS codes anyway. So I don't think it should cost a lot. I think actually the benefits will outweigh the costs for the ports.
Okay, interesting thought. So there's a number of folks that are working on port electrification and so on. So maybe we can connect you across to those groups as well.
Yeah.
So we'll follow up and maybe connect the different groups. And there's a group led by folks from Greece. So maybe have a look at that. I see one more point from Peter Lang to check out Thorcon for ship-to-shore power generation information. So
yes.
maybe have a look at that. And I think I truly have exhausted the comments. One more message. Sorry, try this. This was from Ipsita. To point out that she will post the recording and most likely will be there tomorrow, maybe sooner. And please share the link to the reporting widely so others can take advantage of this wonderful presentation, eye-opening presentation for us, and also this great discussion that we had here. So with that, I'd like to thank everybody, in particular Jan. It was great meeting you. And I look forward to continuing our discussion and engagement. Thank you very much, everybody.
Bye-bye.
Yeah, thank you.
Bye-bye.
Good day.